Hey guys, so tonight I wanted to talk to you a little bit about function notation. So we started talking about functions last week, and today we're going to think about them in a little bit different form. So we've looked at coordinates, we've looked at charts, we have looked at graphs of functions. So we've been able to identify whether or not something is a function. We've talked about things like domain and range so that we understand what the inputs and the outputs to a function are going to be. But what I'd like to look at with you this morning is how we write functions as a rule. So let's consider for a moment this situation where we're going to go to the store and we're going to buy Snicker bars. And each Snicker bar is going to cost us $2. So when we go to the store to buy this candy, if we wanted to write a rule to represent the cost or total cost of candy, we might write something like this. The cost is equal to $2 times each Snicker bar. Notice that for the first time, we have two variables in our equation. Okay? The C in this equation is representing our total cost. This is our total cost. And we don't know what the total cost is going to be because our total cost depends on the number of Snicker bars we buy. So for example, if I wanted to create a little chart here that was comparing my cost to the number of Snickers, if I bought, my apologies guys, if I bought let's go back here. Let's undo that. Undo. I wrote that backwards. My apologies. So let's put our Snickers over here. If I bought one Snicker bar, then 2 times 1 means that my cost would be $2. And if I bought 5 Snicker bars, then my cost would be what? Right. So we'd plug 5 in for S, and 2 times 5 would give us a cost of 10, absolutely. And that's how we're going to use function rules. But what I want to talk to you guys about today is a slightly different way to write the exact same rule. So let's take a look at the rule that we wrote on the last page. That was C equals 2S. And when we're going to write things in function notation, we write it just slightly different. We're going to write still equals 2S because what our equation part, the expression that represents our cost, is going to be the same. We're going to say that it is 2S. But instead of using the variable C, we're going to say f of s. And what f of s means is that my output is a function of s, which in this case stood for Snickers. So essentially, all we're doing here is we're replacing the variable c with a new variable that we're calling f of s. Please do not get confused by the parentheses here. That doesn't mean f times s. What it means is I have a function, and in that function I'm plugging in s, f of s. And so, if I want to make a little chart again, I'm going to have my input-output. We're going to have s and f of s. What we're really looking at here is if I plug in, let's say, 5 Snicker bars, then what I'm asking you for is, what does my function equal at 5? Well, my function at 5 is equal to 2 times 5, which is, of course, still 10. It's a slightly different way of writing the exact same thing. Now, you may be asking yourself, why would I want to write it like this? Why would I want to write function notation like this? And I'll tell you what the value of it is. The value of writing function notation in this way with this f of variable is that when I write my answer, for example, I want to know what happens to this function when I plug an input of 5. So go ahead and tell me real quick. If I plug in 5 in this function, what am I going to get as an output? Cool. So if I plug in 5, then what I'm saying is my function at 5 is equal to 5 squared. So my function, when I plug in 5, is equal to 25. And the value of writing my function in this way, instead of in a way that we would have done it before, is that my final answer not only gives me the output, but it also tells me what my input was. So in that single line, I know the input and the output. My function, when I input 5, is going to have a value of 25. So using that information, I'd like you to try to find f of 7. Go for it. Yeah, if we want to find f of 7, all I'm asking you to do is to plug 7 into the function. So instead of x, we're going to write 7 squared. Therefore, f of 7 is 49. When I put in 7, out pops 49. So hopefully you can start to see the value of writing the function in this way. By using this function notation, f parentheses variable, we can see the input and the output at the exact same time. So let's check out a couple of examples that I want you to do. Let's check out first, we're going to have f of x equals x squared plus 3. And I'm going to ask this question in 2 different ways. First, I want you to find f of 10. Let's do that first. And so yeah, f of 10 is just going to be equal to 10 squared. That's a 10. Let's go back here. I got messed up. Let's fix it. Wow, that doesn't want to go back anymore, does it? Oh, there it goes. Cool. So let's write that. 10 squared plus 3. That's going to be 100 plus 3, which is 103. So that's one way we want to be able to answer this. And the other way we want to be able to answer this is if I tell you that the domain of this function is 3, 4, 5, I want you to try to tell me what the range of this function is. And of course, we know what the words domain and range mean. What does domain mean? Okay, and what does range mean? Right, so our domain is our input, our range is our output. So if I am inputting 3 into my function, if I'm putting 3 into my function, well, 3 squared, 3 times 3 is 9, plus 3 is 12. And if I'm inputting 4 into my function, then 4 squared, or 4 times 4 is 16, plus 3 is 19. And if I put 5 in my function, then 5 squared is 25, plus 3 is 28. And there's my range, 12, 19, 28. So in this example on the left that I gave you, I'm asking you for one specific input-output pair. And on the right, I'm using domain and range to ask you about multiple input-output pairs. All right, so we're going to go to our last question right now. I want to see how you're doing on this. I'm going to give you just a series of things I want you to try to answer. I'll show some explanations in between, and then we'll be done with this video. So what I'd like you to think about for a moment is I want you to write me a function rule for the following situation. I go to the bowling alley, and I rent shoes for $5. When I go to bowl in the bowling alley, they charge me $3 for every game. Write a function rule that will represent my total cost for going to the bowling alley if the shoe rental costs $5 and each game costs $3. Go for it. All right, so we should have something that says that my parts is equal to my total. The parts here are the $5 I'm paying for shoe rental and the $3 I'm paying for each game. And the total is whatever my total cost is. And if we're writing this in function notation, we're going to say the function of G, because G is my variable. It represents games. And generally, we write this the other way around. We write f of G equals 5 plus 3G. And what that means is my function, when I plug in a number of games, will tell me what my total cost is. So given that, I would like you to tell me what the cost of playing 7 games. If I want to bowl 7 games, how much is it going to cost me using my function rule? Go for it. All right, let's see if you got it right. So we're going to say our function, when I play 7 games, is equal to 5 plus 3 times 7. And 3 times 7 is 21, and 21 plus 5 is f of 7 is 26. So my function tells me that if I want to play 7 games, it's going to cost me $26. I hope that this lesson went pretty well for you. I hope you understand why we use function notation. I hope you understand that f parentheses does not mean multiplication, but instead it actually means the function using this input, f of 7 meaning the function using an input of 7, gives me an output of 26. So hopefully you understand that. Hopefully we continue to remember what those words domain and range mean. And we will continue this discussion tomorrow in class. I hope you guys have a good night, and I'll see you tomorrow.